Next topic in unit 3 is interfacing sensors with the Arduino. So under that, first is controlling LED, second integration of LED and switch. These are the two topics under this session. So first one, controlling LED, how we are going to control the LED with the connection as well as the program. So first LED. LED is an electronic component used to emit light when an electric current passes through it. So these are the most common LEDs available in various colors, like including red color, green, blue, yellow and white. They are widely used for indicating light displays and general lighting. So basically LED is used for lighting and you have in different colors. Next, interfacing this LED with the Arduino board. This is the Arduino board and this is the LED. Now how we are connecting the LED pins to the Arduino board, that we will see in this description. Connect the longer LED, that is anode, to the current limiting resistor. So for LED you have two pins. So first one pin, that is anode pin, you are connecting to the current limiting resistor and the voltage source to one of the pin of the Arduino board. Example, 5 volts for most standard LEDs. You will be having 5 volts as a most standard volts for the LED, and the shorter LED cathode you are going to connect it to the ground. So first one, with the help of resistor you are going to connect to any of the digital pin of the Arduino board, and second pin of the LED you are connecting to the ground of the Arduino board. So use a current limiting resistor to protect LED from excess current. We are using this resistor because to protect it from the excess current. For example, 220 to 330 ohms resistor is commonly used for the LED. So this is the connection, how the LED is connected to the Arduino board. So for same this you are going to write the program. So the program for the previous slide is, you are declaring some constant variable, constant int LED pin, and is equal to 13. 13 means you are connecting 13 pin of the Arduino board to the LED along with the resistor. This is what we are writing in the program. Constant int LED pin is equal to 13. Digital pin of the Arduino board is connected to one of the pin of the LED. Next, void setup. In void setup you are writing pin mode method to make it the LED pin as output. So pin mode, in the parameters are LED pin comma output. You are setting up the LED pin as output in void setup method. Next, in void loop you want to see whether the LED is on or off. This is the experiment. The output of this experiment is, you are trying to control the LED turning on or turning off. This is the logic we are writing in void loop. So digital write LED pin comma high. High means the LED is on. You are writing a method called as delay, and next digital write LED pin low. Low is turn LED off with the delay 100 milliseconds. So it is waiting for 1 second. If you are not using this delay method, first you try without using this delay method, just digital write LED pin high, digital write LED pin low. So continuously the LED will on and off, on and off. If you want to wait for some time, the LED is on, you want to wait some time, and after some time you want to off the LED, then you are using this delay method. So this is the program for that particular concept, controlling the LED using Arduino board. And the second program is integration of LED and switch. First program you have seen integration of LED with the Arduino board. Here we are using integration of LED along with the switch, that push button. So for this, what is switch? First definition of switch is an electronic component that allows or interrupts the flow of electric current. It has two states, on and off, open and closed. So when the switch is pressed or toggled, it changes its states from one state to another state. If you are not doing nothing, then it means the push button is off. If you are pressing it, then the push button is on. So these are the two states of the push button. Next, how you are interfacing this LED and push button with the Arduino pin. That description, it is written here. Connect one terminal of the push button to the digital pin of Arduino board. So we are connecting one pin to the pin 2. Next, connect the other terminal of the push button to the ground. So another pin you are connecting it to ground. Next, connect a resistor, typically 10k ohms, from the same digital pin, that is pin 2 to 5 volts supply to create an external pull up resistor. To create this external pull up resistor, you are connecting to 5 volts, pin number 2 to 5 volts. So why we are using this? The difference between this connection and the previous connection is there logically you are writing the program so that LED is on or off. Now we are working it with the push button. When you are pressing the push button on, then LED will glow. If you are releasing the button, then LED will be off. In order to do this, you are using two sensors here, push button as well as the LED. So for this, when you write it as a program, you are taking two constant variable here. Constant in push button pin, you are connecting it to 5 pin of the Arduino board. Next, constant int LED pin is equal to 13. You are connecting LED to 13 pin of Arduino board. Next, in void setup, you are writing pin mode method, pin mode button pin comma input, because input is given through the push button. What are the action you are performing in the push button, based on that LED will be glowing on or off. That's why we are taking button pin as a input. Next, in pin mode, LED pin output. LED pin is the output pin, that is the output here is LED sensor, input is the push button. With a serial dot begin 9600, with a baud rate you are doing serial communication, that's why you are using serial dot begin method. Next, in void loop you are writing the main logic. So int button state, what is the button state? That is status of the button, whether you are pressing or releasing. That is the meaning of int button state is equal to digital read button pin. So read the state of the button. What in the button, what are the state that you are reading with the help of digital read method, and it is stored in button state. So what is the output within this button pin is stored in button state. Next, serial dot println button state. What is the status of the button, whether it is pressed or whether it is released, whether it is on or whether it is off, that is stored in button state with the previous statement. So that you are going to print it on the serial monitor. Now if button state is equal to high, then digital write LED pin is equal to high. If the button state is high, means say you are pressing it, then LED should glow, that's why LED pin high. In the same way, else digital write LED pin low. If you are releasing, then LED pin is low, that means the LED pin is off. So this is the logic you are writing based on the status of the variable button state. Thank you.